Good morning, everybody. Anybody from the West Coast? No? All right. It's just early for me then. So, all right. So everybody, thanks for coming. Really appreciate you attending the first session of the day here. You had a lot of options. So today we're going to talk about how to use enterprise backup and recovery as a fulcrum for enabling hybrid cloud storage in your organization or your environment. So first we're going to talk about some simple steps to get started. We're going to talk about ways to lower costs. We're going to talk about ways to increase some scale with your existing backup and recovery solutions. And I think a lot of times people pick backups because you can isolate them from other workloads in a much more simple fashion, right? So even if that's not the case in your environment, whatever your reason for attending, we're going to do our best to make sure that this is a worthwhile session for you. Just out of curiosity, who cares more about content and less about Q&A? A few people. Who cares more about Q&A and less about content? Nobody. OK, all right. OK. So we'll go longer then on the content and less on the Q&A. Some people care a lot more. I did a webinar a few weeks ago, and the vast majority of the time was spent on Q&A. We actually stayed after the slot because the questions just kept coming. So if you have a lot of questions that you want to ask, I'll stick around afterwards, and I'll do my best to answer them. Also, check out the AWS booth. There's an Ask the Experts group there. A bunch of solution architects will be there to answer questions. And in addition to that, I think there's also a partner booth. So the partner ecosystem is a big part of this presentation. So if you have questions about partner solutions or the APN partner network in general, please feel free to stop by. So this is me turning off my phone, so no interruptions. Awesome. Cool. All right, so why hybrid cloud? Well, you want to be a hero, right? So I think backups are one of those things that everybody does or should do, and they don't always get an opportunity to get the right kind of resource planning. You know, who's going to get the resources first? If you have a budget for a shiny new storage array, is it the money-making production workload, or is it the aging backup infrastructure that's on its last leg that's going to get the new budget? At a lot of places, it's the production workload, and maybe rightfully so. But the nice thing is that with the cloud, you don't actually need that shiny new storage array. You only pay for what you use. You never have to provision anything, and it scales to what you need. So all the while, you're actually simplifying your backup strategy and your recovery strategy, too, as a result. You combine all this, you really do get to be the hero, because backups are really about saving the day. It's for those situations that you didn't plan for. When you need those backups, where would you rather have them? In the most scalable and durable object store in the history of human beings, or on a flimsy magnetic tape with bit rot bouncing down the freeway, on its way to being mishandled maybe by a technician who doesn't care about your data? Personally, I'd rather have it in S3 or Glacier. So that's what this is all about. It's about fulfilling the promise of recovery. So we're going to touch on all the ways that you can back up and restore in a single bound, no cape required. So this is the way things used to be. At one time or another, almost all enterprise backup and recovery scenarios looked like this. If you wanted high-performance data access, it had to live on disk. If you wanted cost-effective archival storage, it had to live on tape. If you wanted to archive off-site, you had to physically deliver your archive tapes to another location. And recovery from a local disk was fine, except if you needed something that was on that tape, and maybe it was a little while before it was on site again. So there's a few things about this story that changed with the cloud. So the first part of the backup and recovery story that changed with the cloud is that the backup software itself was given the ability to write to the cloud without any changes to the backup software itself. And we accomplished that with cloud gateways. So there'll be a section in this presentation about cloud gateways. A cloud gateway, if you've never heard this phrase before, what it lets you do is give you a centralized way to persist data in the cloud, but still keep, in some cases, a locally cached version. And that cloud gateway, by the way, didn't just replace the tape libraries. It also replaced the truck. Instead of having fossil fuels to transport your data from point A to point B, commodity internet is now the carrier. So we'll talk about two gateways. We're going to talk about the AWS Storage Gateway, and we're going to talk about the NetApp All-to-Vault appliance. The second part of the backup and recovery story that changed with the cloud was that backup software makers started putting the ability to write directly to the cloud in their software. A lot of the market leaders of enterprise backup solutions today have native cloud connectors. All you really have to give them is, what are your credentials? What is the service that you want to talk to? And by the way, it's not just AWS. They talk to other object stores. And a lot of times your bucket name, right? So maybe if you're doing some encryption, some key management stuff. But after that, you're off and away. You can start uploading today if you have software that has a cloud connector natively enabled in it. So the enterprise backup software partners that we've had a lot of success with, Commvault, the Sampana suite, Veritas, NetBackup. And we've, as an organization, we've tried to build relationships with the makers of enterprise backup software to enable cloud connectors on those platforms. There's other market leaders, and then there's also a lot of smaller players that we're also working with. But by far and away, Commvault and Veritas represent the largest, let's say, single segment of the market. So before we get to the rest of it, I want to just go over, you might have noticed in the last slide, actually, that there's some stuff there, these guys here, Amazon S3, S3IA, and Glacier. I just want to explain what that means. This is a getting started session, so I don't want to make any assumptions. If you've heard of S3IA, would you mind raising your hand? I know the audience participation maybe is a little lame, but all right, thanks. Okay, cool, great. So S3, probably everybody's heard of S3, right? It was the first service to come out on AWS. And it's ridiculously durable. It's object storage. For all intents and purposes, it could be file storage, right, if you store a file as an object. EBS, it's block storage. So if you don't know what block storage means, you can think about things like local disk. If you have a data center with fiber channel storage or an iSCSI appliance, that's block storage. The only difference is that in AWS, it's a managed service, right? It's not something that you have to manage, just like all of the other things in AWS, right? So S3, globally, highly scalable. We have actually web properties that do 200 gigabytes a second out of one bucket. So if you are concerned about performance, let me set you at ease. If you use our best practices when interacting with S3, it can go as fast as you want it to. EFS, still in preview. Think of it as a centralized NFS server. We're working on adding other protocols and expanding the feature set. Just like everything in AWS, it starts out at an MVP level. We want to get it out the door and then start adding features. And then lastly, Glacier. Glacier is really one of those things. The rule of thumb with Glacier is if it was on tape before, it's okay for it to be on Glacier now. If it wasn't on tape, I recommend evaluating the pricing model, making sure that you understand what the restore scenarios for your information might be, because it could influence which one of these storage solutions you actually put your data on. Okay, so what's common to all of these services is that since they're all running on AWS, there's no need for you to put any upfront investment. There's no commitment. You only pay for what you use, and you don't have to perform any complex or risky capacity planning modeling. All of them were designed for very, very high levels of durability and availability, and they allow you to pretty quickly and easily provision as much capacity as you want or need without ever really worrying about running out of space or hitting bottlenecks. So, cloud gateways. The first thing that changed with that backup scenario. So 2 excellent options, AWS Storage Gateway and NetApp All-to-Vault Appliance. They can both run on-prem or in the cloud. They have lots of different sizes in the sense that when you run the AWS Storage Gateway on-prem, it's a virtual appliance, so it's running on your hardware. You talk to it via iSCSI. So if you want it to go faster, you give it more resources. If you want it to have more capacity, you provision more capacity for it. It can also run inside of AWS, but what we try to push people to is if you're running AWS Storage Gateway on-prem, you can actually access the contents of the volumes that you provision as EBS volumes. You take snapshots of what's on the storage gateway, and then you can instantiate those as EBS volumes. So you don't necessarily need to run it inside of AWS as an appliance, but it is an option. And then it talks to a backend. So you have your on-prem component, goes over the internet or it goes over Direct Connect. Does anybody not know what Direct Connect is? If you've never heard of it before? or one person. So it's think of it like a private line, right? So Direct Connect is literally a direct connection into AWS, and it goes over the normal fiber carriers that you would think of when you go get like a lease line or a private line. And it's totally provisioned for you. So if you get a 10 gig line, you have a 10 gig line. You're not competing with anybody. And it actually talks to this AWS Storage Gateway. Actually talks to a backend service that runs on EC2. And then that backend service arbitrates all of the traffic that you send it into either S3 or Glacier, or in the case of snapshots, you can send it directly to EBS via snapshots. So all the traffic is HTTPS, so it's firewall friendly and secure. And the way that you actually instantiate Storage Gateway is through sort of a wizard workflow on the console. So it's really easy. It's super, super easy, actually. But I want to drill down to how the Storage Gateway can be used. So there's 3 deployment architectures. The first deployment architecture is what we call the stored volume architecture. And in this mode, data is stored on the hardware, and it's asynchronously backed up to AWS. So what that means is that you get low latency access to your data set. And when you use this mode, all the storage is fully provisioned. So that means that when you create the volume of a certain amount of size, you have to have that amount of storage available to it. It's not thinly provisioned, it's fully provisioned. Think of it as a thickly provisioned volume. Egress pricing is one of the reasons, the main reason, really, why people often choose to have a cached copy of the data that they're sending up to the cloud on-prem. So especially for the backup and restore use case, when you want to do your daily restores for either recovering a file or re-imaging a laptop, these kinds of things, having to go out to the cloud every single time seems a little bit unnecessary, right? If you have a copy of all of that data cached and hot on-prem, you should go over your local network. The performance is better, the user experience is better, and it costs nothing. So this is really ideal for those everyday restore scenarios that you have in your backup environments. The second of those 3 deployment architectures is called the cached volume architecture. And so what that means is, whereas the previous one was thickly provisioned, this is actually thinly provisioned. So your data is stored in AWS, so you go to a write. It's not asynchronously written, it's actually synchronously written up. That's the only way that we can make sure that what's actually readable on the AWS Storage Gateway is truly a cache and not a persistent copy of that. And then, so you get low latency access to really just what you've accessed recently. So if you store, think about it, if you've got a terabyte of data up in the cloud and you've provisioned the cache size to be 1/10 of that, then whatever is hot is going to be locally accessible. And then as the hot data set changes, it's going to start evicting things from the cache. So size your caches correctly. So when you use this mode, as I mentioned, everything's thinly provisioned. So what that means is you don't actually need to have that 1 terabyte of storage. You could actually have less. So for virtualized environments, it's kind of ideal since people try to get away from things like centralized storage. They want to be able to have a smaller footprint in the data center. And then the third of the 3 deployment architectures is called the VTL, or the virtual tape library. So this is actually supported by a lot of very standard, let's say industry standard application suites. So you actually talk with your backup software directly to the storage appliance using this VTL protocol. So the things that are on our certified list are NetBackup, Backup Exec, System Center by Microsoft, Veeam, version 7, 8, and then 9 unofficially. Soon it'll be officially supported. But if you use Veeam, file a ticket with support, they'll help you out. Dell NetVault and EMC Networker, the former Legato Networker. So if you use any of those things and you desire to actually have, let's say, an extension into the cloud, you would actually talk to a virtual shelf, and there would be virtual tapes that live in that virtual shelf, and it would all be backed by Amazon Glacier. Another cloud gateway product is the NetApp AltaVault. So this is the only partner cloud gateway product that we're going to talk about today. There's more, but I'd like to focus on this one because I think that AWS Storage Gateway is at one end of the spectrum for people who are interested in very, very cost-effective, great set of entry-level features. And then AltaVault's at the other end of the spectrum. It's a bit more expensive, but it has a lot more features. So this was originally a Riverbed product. It was codenamed Whitewater. It was acquired by NetApp. And this product was created to accelerate backups. This was specifically for things that did not have a cloud connector. It supports NFS, it supports SMB. So iSCSI on the AWS Storage Gateway, NFS and SMB on the AltaVault. And so if you're looking for CIF support, that's where you'll find it. AltaVault has a hardware appliance option. It's not just a virtual option, so you can deploy it as a virtual appliance if you want. It also has an AMI option, and we'll go into that in a second. There's a couple of reasons why customers sometimes choose hardware appliances over software products. I mean, if your hot data set's pretty large, then you might actually need to get shelf expansion kits to accommodate your cache size. If you have high performance requirements, if you're sending a huge amount of data, like, well, let's call it 50 terabytes a day, if you really need to be able to send that much data into the cloud, most likely a virtualized option is not for you. You probably are interested in using one of our other things like a Snowball or using AltaVault. So the amount of data that you're sending in the cloud would dictate the kind of performance that you need. This thing was designed to keep up with the toughest workloads. So how do you get it? Well, so this is the part that's a little bit subtle, actually. It's available in the AWS Marketplace. So when you want an AWS Storage Gateway, you just go through the console. You click through, you log into the normal AWS console. It's not the Marketplace, it's just the normal, hey, this is where I go for EC2, this is where I go for S3. You can turn it up with the sort of wizard workflow. When you go to turn up a partner solution, very often you're going to go through the AWS Marketplace. So once you've got it, everything else is the same in the sense that you run it when you want it and you turn it off when you don't. You pay for the storage that you persist in S3 or Glacier, but the EC2 resources, it's consumption-based pricing. You don't pay for it when you don't use it. So that idea that you only pay for what you use really is a hallmark of AWS services, and we provide the same consumption-based pricing opportunities to traditional independent software vendors too, people that traditionally you wouldn't have been able to do that for. If you want to go buy the hardware appliance, for example, it's not like you get to stop paying when you turn it off at night in your data center, even though you might only really be using it for 8 hours a day. You have to pay for it all the time. So that's a serious advantage to running it inside of AWS. And then lastly, since it was designed to accelerate the transfer of data to the cloud, what you'll find is that there's some technically differentiating features. So AltaVault has inline deduplication, it has compression, encryption. AWS Storage Gateway has encryption, right? And it has compression over the wire, but it doesn't have deduplication. So if you believe that you have a really, really, really sparse data set, like virtual machine images or something like that, where you have 1,000 instances of something on-prem and you think it can all be compressed down to the equivalent of maybe a dozen instances, you wouldn't be able to get those kinds of savings with Storage Gateway, but you would be able to with AltaVault. So sometimes, depending on your circumstances, you might find paying a little bit more for the solution that you're using, like AltaVault, actually gives you long-term benefits to being able to do things like Dedupe. So moving on to cloud connectors, a lot of this will probably look pretty familiar to you if you're familiar with enterprise backup suites. At the center of it all, you have a master server. You have protected endpoints that execute agent software that talks to the master. You get a set of policies. You get media agent locations or media server locations, depending on what software suite you're using. They use different phrasing. But what's new with the cloud is that, for example, in Simpana, you go and you create a cloud storage library, and that invokes the Commvault Simpana Cloud Connector under the covers, and that allows you to send your backup jobs to S3. So then Commvault took it one step further, and they said, well, what about Glacier? Customers should be able to integrate with Glacier. So they took advantage of what's called a lifecycle policy. Our lifecycle policy feature lets you migrate from one storage class to another. If you remember that slide where we had S3 and we had Glacier and S3IA, those things, right? So S3IA, infrequent access, is a storage class inside of S3. So that means that you have S3 standard, you have S3IA, and then if you wanted to, you could migrate things off to Glacier as well. We provide a storage class for being able to migrate between services. S3 being one service, Glacier being a disparate, distinct service. So this is actually quite important because when you look at your traditional backup infrastructure, you have policies that say things like, I want to retain a certain number of days worth of data on-prem, and then I want to migrate it off to maybe a cheaper nearline storage system, or I want to migrate it off to tape. This gives you the ability to do that inside of the cloud. So let's say, for example, that you want 30 days of backups going to S3 because you know that inside of 30 days, you're okay to do recoveries, and maybe you have a policy internally that says after 30 days, it is, maybe it used to be on tape. So like I said before, if it used to be on tape, it's okay for it to be on Glacier because the recovery scenario is such that the SLAs that you would have to meet when it used to be on tape are probably significantly longer than what they were on disk. So same thing here. The recovery scenario of getting something out of Glacier is significantly longer than getting it out of S3. So what's more, actually, is that Commvault, with their Sympana suite, was the first enterprise backup suite partner to integrate S3 support. And they released it very, very shortly after we announced its availability. And the goal, of course, of being able to migrate things to Glacier is cost savings. So we'll switch to NetBackup now. It's pretty much the same, but there's some terminology change differences. So the way they call media agents, they actually call them media servers, and the policies that indicate that the data be placed in the cloud, they don't use the phrase cloud library, they use the phrase cloud storage disk pool. So if you go look in the documentation, you'll find that all these concepts are fairly analogous to each other. One backup software suite often works very similarly to another backup software suite. From a cloud connector perspective, in Sympana, you do have to tune things a bit sometimes to get the performance that you're looking for. The Veritas one, it's all auto-detect. There's no tuning required. But both of their cloud connectors can give you extremely high levels of performance. I've seen customers that had backup windows from Friday night to Sunday night, and they were doing 4,600 to 5,000 backup jobs in that time frame. And they were able to actually deliver those persisting inside of S3. It wasn't like they were just getting them into their media agents. They were actually able to send it up to the cloud. So if you are interested in super, super high performance, you can get it. Very often it means that you might need more than one media server. However, in most even huge backup environments, I haven't seen the need for a lot of media servers, right? Maybe 2 to 4 maximum for even tens of thousands of protected endpoints. And then lastly, once the data is in the cloud, the recovery options really start to open up. So what does that mean? Well, it means, let's say you're backing up VMware images, and you have a recovery scenario where you want to actually restore those to an AMI and run them inside of EC2. Sympana will do that conversion for you. You don't have to go through the import image process and do it manually. Other software suite combinations, using Veeam, for example, in combination with NetApp AltaVault, give you the ability to spin up an AltaVault appliance inside of EC2 and read the data back out as well. So the idea of, okay, I've backed it up, but now what? You actually get to carry that forward inside of the cloud by being able to do an automatic conversion to an AMI format. So where that goes is, how do you do that at a data center scale? So the first question is everything backed up? And maybe you weren't even able to do it before. Maybe cost was a consideration. You couldn't provision, for example, enough storage to be able to do it because you knew you'd have to buy more storage than you needed ahead of time in order to back up less than the capacity of that storage system today, right? So with the cloud, since you're actually just paying for what you use, you have that ability now to send everything up, and then if you actually do need it, recover it into the cloud. And that's where the lifecycle policy stuff starts to get really important because I think you probably know this about your own infrastructures. The vast majority of the recovery cases are accidents. So for example, with Glacier, there is a 5% of what you've deposited into the vault you can restore for free. And so what that means is that if your recoveries are few and far between, then as long as you can wait for that timeline for the restore window of a few hours sometimes, that means that you can actually, your recoveries cost nothing, right? If you have recovery scenarios that happen all the time, then maybe Glacier isn't the right place for it. So, other elements, catalogs, master servers. You do have to do the right things when it comes to these components. The nice thing actually is that all of these partner solutions have documentation around how to have multi-master clusters, or how to fail over from an on-prem environment into the cloud, how to do catalog duplication. Veritas, for example, has their own protocol that they certify partners with. And so some of those partners who actually take the steps to do the work to integrate with their protocols can do things like catalog replication for you. You don't have to do anything, right? There's no exporting, there's no importing. You just install, for example, StoreReduce is a inline deduplication gateway. And you tell Veritas, instead of talking to S3, I'm going to talk locally to my StoreReduce instance. StoreReduce does inline deduplication, sends it up to S3 or to S3IA, and then on the other side, when you want to pull data out, you instantiate a StoreReduce AMI, and as you pull it out, it rehydrates the content. Well, StoreReduce is integrated with the Veritas NetBackup internal protocol, so they can actually duplicate the catalog. So let's say, for example, you have Veritas NetBackup deployed across your entire on-prem DC infrastructure, but you're sending all the data up to the cloud via StoreReduce. When you go do that recovery into the cloud because your data center blew up or you had a once in 25,000 years event, the way Colorado Springs did 2 years in a row, right? They had fires and floods at the, back to back. Those kinds of events, you can't predict them. So what happens when you have these catastrophic situations? So you end up having to do huge amounts of restores. Well, when you go to do that, all of that data is useless without the catalog. So having a copy of the catalog is critically important. So if you're not doing the manual or semi-automated process for actually doing the backup of the catalog and the master config and all of these really important parts that you sort of set it up at the beginning and then oftentimes you forget about it, consider integration with an application that actually will do it for you automatically. So the other great thing, obviously, about being inside of AWS is that when you want to do that restore, if you have large instances, let's say you use an instance with a 10 gigabit connection, the cost of instantiating that instance and pulling data out of S3 at 10 gigabit rates is substantially lower than what you would be able to do on-prem. There's no transit internet upgrade required. There's no direct connect link required. Direct connect, even though it's a service, it still goes through a fiber provider, so you get locked into contracts. So the idea of being able to do the restore inside of AWS gives you a lot more freedom and flexibility. So now we're going to talk about Active Archive. This is a sort of a new term. And you might remember that last year we introduced the Snowball. So it was 50 terabytes at the time. It has just received a 60% more capacity upgrade. It is now 80 terabytes. This improves upon our traditional import-export disk service in several ways, all, by the way, based on feedback that we received from customers. This device is ridiculously cool. I guess in their testing, they even did stuff like throw it off roofs to test the ruggedized components. I don't think we recommend our customers do that, but the idea that they actually tested that was pretty awesome. So what it does is it offers petabyte scale data transfer. So how do you go to petabytes from 80 terabytes? Well, you use them in parallel. So the cost is per job. It's cheap enough that you could even keep it and use it as a storage component. And the main difference, I would suppose, probably from the original import-export is that with the original import-export, you had to buy the disk. And so this is Amazon hardware. You just lease it from us for a short period of time. So we ship it directly to you. You can actually see, I don't know if this shows up. This is actually an e-ink display like on the Kindle. And it automatically has the right shipping address there. I think that's pretty cool because the way that it works physically is that after you're done putting your data on there and you turn it off, the act of turning it off and declaring that the job is done is what causes the e-ink display to change. And so you look away and then you look back and it's like it's going back to Amazon. It's such a cool use of repurposing the technology that Amazon pioneered. So it's very secure. It's very fast. how secure is it? So it's a 256-bit encryption process. No data goes on the device that is not encrypted. It is all encrypted ahead of time. So you have to use a client, and we're working on an API for integration with partners, but today you have to use a client. So what that means is, just like with the AWS CLI tools, you install a set of CLI tools onto the system that you want to move the data onto the device from. You define a job. You tell it, okay, these are the details of my job. This is the data that I want to pull from, and I want to send it to the Snowball device. You say go, and then you walk away. And so it goes and fetches all of that information. That it doesn't have to be on the system that you've run the CLI tools from. It could be remote. It could be on an NFS server or something like that. It just needs a file system path. It's not a block device. It's a file interface. So you can think of it as a NAS device, realistically. It doesn't talk NFS, but it's still a NAS device. So it supports all the normal common network interfaces that you would expect. So it has SFP plus interfaces, right? Can you see that there? I guess you can't. But it has SFP plus interfaces, so if you have 10 gig copper, you have 10 gig fiber. If you don't have the 10 gigabit interfaces, that's okay too. It has 1 gig interfaces as well. We're working on even getting faster interfaces. It's, I would say predominantly the people who use this often have more than 80 terabytes that they want to move. It's perfectly okay to use multiple Snowballs in parallel. You just need to have multiple machines that can talk to it. So if you have a machine on a 1 gig interface and you plug your Snowball into a 10 gig interface, you probably need to understand that it's going to go slower, but it's going to go slower because you use that 1 gig interface machine to put the data on there. So just think about the way you're connecting things. Make sure you don't have any bottlenecks. It's super durable. It can survive 8.5 Gs of force, which is much more than the human body can sustain. I don't remember what we black out at, but it's like 2 or 3, right? So it's dust-proof. It's water-resistant. So the idea is that it doesn't come in a box. It just comes like this. And when you ship it ships back just like this. So there's no packing materials for all the data center people to say, no, fire hazard. You don't get any of those kind of flack. I mentioned that the e-ink display actually updates when you're ready to send it back. And it can only be shipped back and forth between AWS. So if you wanted to send it to somebody else, for example, if you wanted to use it as a data distribution mechanism, you can definitely do that, but it's 2 steps. Step 1 is you got to get your data into the cloud, and whether you do it with Snowball or you do it with something else, doesn't matter. Step 2 is you can export the data from S3 onto a Snowball device. We will do it for you. And then you can send the data via Snowball to somebody else. So why would you do that? Well, there's a lot of places that don't have internet connections still. So what we've actually heard mines, remote, like docks, places with boats, where they want to have geological survey data offloaded from the boat directly onto the Snowball, and then ship it back to AWS, load it up into S3, and now run an EMR job on the geological survey data. I think that's so cool. If you wanted to do that yourself, you would have to supply power. I mean, you still have to supply power, but this thing takes normal power, right? Imagine bringing in like a big, heavy NAS appliance or something. It needs cardboard, box, shipping container stuff. It needs a stable operating environment. It wouldn't be dust resistant. It wouldn't be water resistant. This thing is all of those. So it's very, very cool. And we're actually working on working with our partners to enable integration so that let's say that you did have an investment in Simpana or NetBackup and you said, well, I'd really like to move all of this data that I haven't accessed in a long time up to S3 and then tier it to Glacier for cost effectiveness. We want you to be able to do that with Snowball. So we're working hard with our partners to do those kinds of integrations so that you don't have to have any manual steps. So how it works? Well, just like a lot of the other things inside of AWS, it's driven from the console. So you access a Snowball service under the import-export link inside of the AWS console. If you have a computer, you can go and do it right now. Once there, you need to create a data transfer job. So there's a few things that you have to do. You have to specify the bucket. You need KMS encryption keys. Encryption is required. It's not optional in this case. We want to make sure that all your data is secure in transit. and then the location that you want to have the device shipped to. So once the device is received, you just plug it in. It can get a DHCP address. Excuse me. If you want to give it a manual address, you can do that too. Then you connect it to the power, and it comes up, gets the address, and it's ready. So the client software, as I mentioned before, it's a command line tool. You have to load it onto a host in your environment, and then it encrypts the data, puts it onto the device. Once the data transfer is complete, you just power it down, the e-ink display updates, and you can send it back. An important component here is that since the data is now in transit, once you put it on your shipping dock and start to send it back, that's not the time to delete all the stuff that you just put there. You want to wait. Okay. Just in case anybody thought it was, I mean, they could still lose it. The thing could get obliterated. You never know, right? So it's rare that these kinds of events happen, but it is your backup, so you want to be careful with it. I'm sure everybody saw the thing on Stack Overflow. Was it Stack Overflow or Reddit? Maybe it was Reddit, about the guy accidentally deleting all of his backups. That was in the news recently. I'm still not sure if it was a prank or not. So the idea, of course, is that you're going to have to reconcile the fact that the data, once it gets into S3, if the data has changed, now you're going to have to send those incrementals back up. So if that's too much work for you, identify a data set that is not changing. Make sure it's something that you haven't had to update. If you don't have a way to determine that, that's a different issue. But please stop by the AWS booth so that we can talk about it with you. We want to make sure that all the use cases that you have in mind for this product are things that we're thinking about. So once the device is returned, we upload it to S3, and then the device is wiped. And it's wiped in a very secure fashion before it's ever sent to another customer. That's the other great thing about the e-ink stuff, is that all of those past addresses and stuff, there's no pieces of paper to get lost. Nobody can rip it off, and in your secure location, for example, nobody can take it off and say, oh, now I've got the address, right? So I suppose they could take a picture of it. But so during this whole process, you actually get notified. Notifications come the way all notifications come about AWS services. They come through SNS topics. So that means that you can get an email. If you want a text message, you can get a text message. If you want to integrate this with your internal processes that are subscribed to SNS topics, you can do that too. So in other words, let's say that you have an internal application that maybe does ticket handling. Maybe you have integration with something like ServiceNow for ITSM. You can take the SNS topic and you can create a ticket or update an existing ticket to do the tracking of these kinds of things. So there's all kinds of options because it's using all of our native APIs. And then once the data is in S3, what you do with it is then up to you. So how fast is it? Well, if you use them in parallel, it gets really fast. But I just want to compare and contrast 5 snowballs with the internet. So with 5 of these things, my mistake, I didn't do the multiplication with the size upgrade. Just increase everything by 60% for free. No additional charge. You can transfer a huge amount of data, right? Hundreds of terabytes. It's respectable in less than a week. And in comparison, if you have a 1 gig link, for example, it could be maybe only 50% capacity that you get to use because other people are using these links for other things. If that 1 gig link is also your office link, you can't, maybe you get to use the full thing at night, but during the day, probably it's being used for other things. And then if we're talking about your data center, maybe you have a burstable link and you don't want it to go over that link because you're going to incur overage charges. A lot of times people have service provider type networks where they have multiple points of ingress and egress. But if you're always talking to one endpoint, then you don't get to balance that stuff out. So if you're talking to S3, maybe it's all going through one point of egress. There's other ways to do that kind of balancing, but by and large, people provision their internet capacity, their transit center capacity for really long periods of time, and they don't think about things like, oh, well, at some point in the future, I'm going to want to send all my backups up to the cloud, so I'm going to need, I'd like to have a 3-year contract, but in the 3rd year, I want to triple my capacity or increase it by a factor of 10. Service providers just generally don't work that way. So Snowball is a great way to circumvent that entire process. So it does use the old numbers, but you can still see that if the link utilization is 50% and you had a 1 gig link, to transfer the same amount of data as 5 snowballs, We're talking about 47 days. That's a long time. And backup people are used to thinking about long periods of time because things take a long time when you have large amounts of data, but that's too long, in my opinion. There's so much stuff that can change in a 47-day period of time. By the time you get your backup there, maybe it's not even worth restoring, right? What if your entire backup window of, your restore window is 30 days, right? It could be completely antique by then. So the idea that you have to actually go and provision a 10 gig link in order to send your backups up, if your rate of change is so substantial, some people find that a little hard to swallow. And I don't blame them because those links are insanely expensive. So Snowball is a very, very cost-effective alternative. So when should you use it? Well, cloud migration. That's obviously the first use case. But data center decommissioning, and then I talked a little bit about it, content distribution, that idea that if I want to send you a bunch of data, I could just get it up to S3 either with Snowball or over time using normal software, and then do the export. Content distribution is pretty neat. There's other ways to do content distribution. You've probably heard of things like Aspera and Signiant. This is so much cheaper than that. Their pricing is tiered and uses they're not proprietary protocols, but there's some secret sauce in their software, which means that you have to have the software and I have to have the software. And maybe our IT groups don't communicate, or maybe it's hard to work together. This solves all those problems. And so the next thing I want to talk about is something that we're announcing today, transfer acceleration. So we have created a way for you to use our backbone. It's a checkbox WAN accelerator. So if you look at existing WAN accelerators, the real issue, of course, is that I have something on my side, like the riverbed, and you have to have the riverbed on your side, or a Silver Peak, that kind of thing. This is one-sided in the sense that when you turn this on, S3 transfer acceleration gets enabled throughout our network worldwide at all of our edge locations. So we have 55 edge locations. So an edge location is anywhere that we use. We have Route 53. Anywhere that we have CDN, which is a CloudFront service. So this means that you actually get yet another way to take advantage of the AWS, we'll call it private infrastructure. So we've already built out all that fiber. We've already built out all those sites. We've got storage there too. So what we allow you to do is piggyback off of our backbone. You can write the data into an S3 endpoint that's perhaps much more adjacent to you than a region. This is particularly valuable if you're maybe 15 or 20 hops away from a region. You might be 3 or 4 hops away from an edge location. So uploading, for example, to that S3 endpoint gives you a way to have the data proxied over our backbone into S3. So from a percentage perspective, it's something like 50% of the internet is within 30 or 40 milliseconds of one of our edge locations. So that's a lot better coverage than our regions. And that is, of course, the reason why we have CloudFront and Route 53 running out of there. If you're not familiar with Route 53, it's our managed DNS service. If you're not familiar with CloudFront, it's our CDN service. If you've probably heard of CDNs, things like Akamai and Edgecast. CloudFront is got, at this point, actually, you can independently verify this through services like Sidexis. CloudFront actually has better availability than worldwide than Akamai and Edgecast. It's pretty exciting. Another example of starting small and building. So this is a managed service. You don't need to do anything special to take advantage of it other than check the box and use the endpoint that gets specified for the bucket on the AWS console. So it's pretty cool, actually. So when would you use Snowball versus the AWS Transfer Accelerator? If you needed the ability to go to a secure site, Snowball is a much better option. If you needed the ability to go into the Congo, Snowball is a better option. If you needed the ability to do the export, both of them are good options. You can take advantage of the Transfer Accelerator in both directions. I would say that uploading daily backups or syncing daily changes, Transfer Accelerator is the way to go. But if you're talking about, oh, I've got petabytes and petabytes of data on tape, I've got 5,000 tapes in Iron Mountain. I want to pull them all into S3. Probably the best way to do that is to bring those tapes back on site, bring the snowballs on site, write the data onto the snowballs. So seed with Snowball and catch up with the transfer accelerator. Tiering. So we talked a little bit about this before, the idea that we have these different storage classes, S3 Standard, S3 Infrequent Access, and Glacier. The idea that you can actually tier your data inside of AWS means that you can optimize your spend. All of the primary object storage durability, 11 nines of that durability, all of that technology for S3 Standard is the same technology that we're using for S3 Infrequent Access. The durability remains exactly the same. The only thing that changes is the availability, and let me explain what I mean by that. The availability means it's available if I make a request and it gets handled on the first try. It's unavailable if I make the request and I get a response back that says, I'm busy, could you try again later? So we have SDKs that we integrate with our services. We update those, and our partners use those SDKs. So if you are to go use, well, in some cases they don't use it, but in most cases they do. So we have thousands and thousands of partners. The vast majority of them use our SDKs. So the vast majority of our partners, when they send something up to S3, they're prepared for the case where something's broken on the internet. They're prepared for the case where the endpoint that they talk to is busy, and they're prepared for the case where something bad happened and we don't know what it is. Sometimes that something bad happened is their TCP session got reset because they just sent a bunch of traffic out their own internet, and maybe their firewall or some form of IDS or a policer on their router took over and said, hey, this is too much bandwidth. That stuff happens all the time. So availability is, did my request get handled the first time? So when we talk about S3, the properties of S3 and IA are the same on the durability front, but infrequent access is a little bit less available by 1.9. So the idea is that sometimes when you're talking directly to S3 and you say, I want to store this object or this file in the infrequent access storage class, it could tell you, that's cool, try again later. And so if you obey what it told you to do and you actually try again later, it might take it on the second try. And so all of the software that talks to S3 and S3IA understands that. But I didn't want you to get confused if you go to the web page later on and you say, well, the durability looks the same, but the availability looks different. What does that mean? Just want to clarify it. It doesn't mean that the service is unavailable. It just means that the software that talks to the service sometimes has to retry. By the way, every time you load a web page, it wouldn't surprise me if you get a retry on at least a few of those components. So if you actually dig into it, you'll find that retries happen all the time. It's just a normal part of living on the internet. So why would you do the tiering? Well, if you look at the cost model for S3IA, even if you pull back everything that you put in on a monthly basis, it's still about 30% cheaper than standard S3. So if you have data in S3 today, take a look at how often you have to pull it back. It might be the case that you can have some pretty immediate and substantial cost savings just by applying a lifecycle policy, and we'll talk about how to do that in a second, to move it from S3 standard storage class to S3 infrequent access storage class. Very, very valuable. And then lastly, Glacier. We've talked about Glacier before. Again, the rule of thumb, if it was on tape, then Glacier is a good place for it. If it was not on tape, do not put it on Glacier just because you want to be able to pay a cent per gigabyte per month. It's a bad idea. Your restore scenarios are what dictate whether or not it should go on Glacier. So use all of these things as, you can think about it as sort of a matrix of durability and price, and use the right class for your data. And understand your data. If you don't understand your data, don't make the decision yet. Take the time to understand your data. And if you're looking for a catch-all, I don't have the opportunity to understand all my data. I don't know what's there. I don't set the policy. I'm given the policy. People tell me I have to store this stuff. As is so often the case in the backup world, you kind of have either we get rid of all of our data too soon, or we keep everything forever. And there's very infrequently somewhere in the middle, right? It's usually one or the other. So especially if you fall into the I need to keep everything forever scenario, put it all in S3. Once it's there, you can use those lifecycle policies on a data set by data set basis to move it into a lower cost tier. So those lifecycle policies. This is actually an example of a real lifecycle policy for doing a log data set, transitioning it from S3 to Glacier after 30 days, and then deleting it from Glacier automatically 365 days after it was created. Pretty standard. You could literally copy and paste this into a policy for a bucket that you have, change the values, and it would work. And you can see actually that we talk about short-term buckets, mid-term buckets, and long-term buckets. That really is the way we think about them. So who's using all this stuff? Well, there's some pretty big names up there. I was pretty excited to see names up there like Huddle and Illumina. Illumina is a bioinformatics company. They make gene sequencers down in just north of San Diego. I forget the name of the town. And they're actually taking data directly from sequencers and sending it up into S3. It's unreal. This is, by the way, this is a workload that used to be sequencer, Isilon on the CIF side, and then on the NFS side, they would go do a bunch of Hadoop jobs on it, or whatever their private, Galaxy I think it was. I think Galaxy was the name of the application that they used. And then they would generate reports based on that, right, for sequencing human genomes. Now it gets to go directly into S3. And I promise you that we have more computers than they did. So that means that for people who care about things like saving their own life, understanding what their genome means for their health, they can actually really, literally get the data much faster. A job that used to take a week now can take a day or a couple hours. Just depends on how much CPU you throw at the problem. So for S3, we've got FINRA. We've talked about, we've got SoundCloud, Illumina, Supercell, Novartis, and Autodesk. Autodesk is another really cool company. They do amazing things. And for the new S3 Transfer Accelerator service, there's already 3 customer references up here, Frame.io, Huddle, and Viacore. Huddle's pretty neat, actually. Does anybody use their stuff, or have anybody heard of them? They do a lot of advanced video stuff as it relates to sports. And then for the Snowball product, we've got some customer references for you here as well. Philips Healthcare, you can imagine how much data they have. It's a lot of snowballs flying through the air. Dev Factory, Zools, Dow Jones, Scripps, and the World Wrestling Entertainment Organization. I'm not exactly sure what they're doing with it, but I have to assume it relates to video archive. Compliance. So I don't know what you guys have planned this afternoon, but Henry Zhang is a senior product manager for Glacier. And he is going to be giving a compliance-oriented talk in room E352. Is that our room? Oh, no, we're 351. Yeah, it's next door. From 3:30 to 4:30. So if any of these things matter to you, the SEC stuff, the FINRA stuff, or the CFTC stuff, I highly recommend checking it out. And stick around afterwards and talk to him. Not only is he going to be giving this session, but because he's a senior product manager for Glacier, he's just an encyclopedia of archival knowledge. I think in a lot of industries, just out of curiosity, who has compliance stuff that they have to worry about? Everybody. Everybody has compliance stuff. And sometimes it's industry specific, right? Sometimes it's FI stuff or HIPAA. Sometimes it's financial oriented. But I would say most AWS customers have some form of compliance that they have to worry about. It's not just about long-term storage. I mean, that's another form of compliance, by the way, right? Your backup policy is a form of compliance. You're compliant or you're not compliant to whatever policy you decide to implement. Everybody gets to benefit from Glacier's durability and low cost, but and also the integration with other services. But when it comes to Glacier, the terminology is a little bit different. So S3 has buckets and objects. Glacier has vaults and archives. They're the same. A bucket is analogous to a vault, and an object is analogous to an archive. So when you have your conversation with Henry, if you use the term buckets and objects, he will know what you mean, don't worry. So in certain industries, obviously, long-term records retention is mandated by regulations, or some form of compliance rule. Sometimes it could be 7 years. And if we go back to this, by the way, if we go back to that lifecycle policy, you could actually throw this into a vault in Glacier and lock it down for 7 years. And it would be impossible to delete it prior to that point. So you can actually do enforcement of your policies with technology. And that gets really powerful. Worm is just, if you don't know what it means, it's a write once, read many. But the idea is that it's immutable. After I put it into this archive, I don't want to be able to change it. All the credibility goes away if you, for what you're storing. Let's imagine that it's a transaction record, for example. All the credibility goes away if you can change it afterwards. So that's the purpose of Worm. So compliance controls, vault lock policies, these are all things that Henry's going to go over. I don't know, there's so many people here who have compliance issues. I would really recommend checking it out. There's a lot more to compliance than just applying a vault lock policy. I think Henry's probably also going to talk about maybe some things that are coming, maybe conceptually. So that's going to be it. We have 4 minutes and 40 seconds left. You guys said you cared more about content than questions. However, I will stick around. I don't have anything to do after this except booth duty, so I'm here to answer all your questions if you want to ask them. Thanks again, and please remember to complete your evaluations.